Okay, welcome everybody to this first online event like this. We've run quite a few at the NSBRC, and I've done this presentation in slightly different forms before to real people. Of course, you're all real people, and we've got more people than we normally get. So I know over 120 now are listening in, and over 300, I think, over the course of the next 2 days. So welcome everybody. I hope that this introduction to Passivhaus will give everybody something, and I'm aware that there are quite different skill levels, and for some this may seem very basic, and for some you might say, oh, what was that? It's a whistle-stop tour through Passivhaus and where we are in the UK at the moment. So just starting with my introductory slide here, this is actually a picture of Goldsmith Street, which is a pioneering project in Norwich, 105 units. The great feature of this, it's all social housing, it's all Passivhaus standard, and Norwich have quite a commitment to Passivhaus. But the key thing here is that this development won the Sterling Prize last year. That's the top architectural prize. So it was a big boost for Passivhaus in the UK. So moving on, these are the things I want to cover today. I've got about 30 minutes, well, 25 to 30 minutes, and then about 10 minutes for questions. We're quite tight for time today. So the first, just to say, what is Passivhaus, if you don't know? And for me, I'm always interested in where do things come from? How do things develop? So where does it come from? I'm going to talk briefly about what the principles are, but mainly, what do you get if you build a Passivhaus standard? How do you do it? And the one that I didn't used to put a slide in about cost, but then it's a question you always get asked, so I now have a couple of slides about cost. How Passivhaus has developed in the UK, so how in the last basically 10 years, how Passivhaus has developed, where we are now, and then some questions for you around your next steps if you want to pursue this further. So I hope it's going to help you give an introduction. We've got a range of really expert presenters over the day, so you'll see a lot of the themes that I talk about repeated again and again in different ways, of course. So let's start with what is Passivhaus. So this is a good place to start. This is Professor Dr. Wolfgang Feist. Wolfgang founded the Passivhaus Institute. He's a physicist. He was actually a particle physicist who became interested in the 80s with a group of others in questioning why buildings were being increasingly insulated and people experimenting with low energy buildings, and it wasn't actually getting people anywhere. They weren't actually reducing energy consumption to any great extent. And he is a very obstinate and tenacious man, I know him quite well, and it set out to find out why this was, going back to the basic building physics and a deep understanding of how comfort works in buildings as well. And a group of them basically developed this row of experimental houses in Darmstadt, which is just a few miles outside Frankfurt in Germany. They got state funding to support them in this experimental work, and it was very experimental at the time. The supply chain wasn't there. They had to develop their own mechanical ventilation system because they didn't exist to the standard they wanted. They had to develop their own window range. So this was very pioneering. Wolfgang and his wife Witte still live in one of these units. There are 4 units there. And recently they've done monitoring on these to show if they're still working. They're still working as intended. The fabric's still good. So they very much proved the concept. Now, the story I've told you about Wolfgang and the fact that they're saying, why don't buildings perform, is a story that we can really repeat here endlessly. And this graph is some work done, I'm based in West Yorkshire, and this is work done by Leeds Beckett University, just down the road from me. They've got the Centre for the Built Environment has done a lot of work monitoring low energy buildings, buildings that are intended to reduce their energy consumption. And what they do is they do co-heating tests, which is a physical test of the building. And each of these vertical bars, pairs of vertical bars, is one building. The blue is what they thought the design was going to be, and the red column is what actually the physical performance of the building when they tested it in terms of energy use. And you can see on average, it's about 2/3 worse than expected. That is called the performance gap. It's the gap between what we think the building is going to do and what it actually does. And here we can see there are only a small sample of Passivhaus buildings, but this is repeated again and again when we monitor Passivhouses. We find that they perform as expected. They're very low energy consumption, and actually they do what it says on the tin, as they say. So this is a story repeated in our industry here, and it's really why Passivhaus is so important to us. So what is it? Well, fundamentally, it's an energy efficient building. It's a building where we need so little energy to heat the building that most of that heat can come from our own bodies, from some solar gain, from our use of household appliances, and from extracting heat from the outgoing air and bringing it into the incoming air. We need a small amount of heat. You do need a heating system in a passive house, but it's technically it's at less than 10 watts per square meter, which is a very small amount of heat. If we reduce any further, we can go to virtually zero, but it's not really cost effective. So this is a sweet point, if you like. But a passive house is also about comfort. It's a comfortable building, and this is incredibly important. What Wolfgang and his colleagues did was look at the building physics in terms of the energy efficiency, but also a lot of the scientific understanding of how we attain comfort in buildings. And I'm going to cover that more in a minute, so I will jump on that. But this is to be borne in mind. Passive house is about both energy efficiency and comfort. There's a very strong technical underpinning to passive house. These are some of the technical metrics for those who work with those sort of things. For those who don't worry about it. But the Passivhaus Institute in Germany is a scientific institute, and the Passivhaus standard has the backing of that scientific work. So what are we looking at? Well, fundamentally, as my business partner says, in my day job, which is as a director of the Green Building Store, Passivhaus Trust is my voluntary work. We've got a mantra, if you like. We've got a series of things we have to do. We also have to insulate well, and that sort of goes really without saying. But when we insulate well, we also need to consider thermal bridges, because as we insulate more, thermal bridges become increasingly important. And a thermal bridge is a point where the insulation thins down or disappears, or something goes through the insulation and acts as a bridge between the inside and the outside in terms of heat loss. While we're insulating, we also need to ensure that we're airtight. So we need to ensure high levels of airtightness, and we'll be looking at that a little bit more later. Our windows need to be well insulated as well, so we'll be looking typically at triple glazed windows in the UK. And we need a mechanical ventilation system with heat recovery, so we don't waste the heat from the ventilation air. And that's the package, if you like. I'm going to come back to this a lot more, but that sort of gives you the framework of what we're basically looking at. It's the fabric of the building. Get that right. So what do you get? Well, you get, as I've said, you get comfort, you get a healthy indoor environment, and you get energy efficiency with very low heating bills. And we're going to unpack each of those and just look at those a little bit more. So comfort, first of all, in a passive house, I want to look at comfort because most people say, well, my house is quite comfortable. And let's have a look at this and see what we actually mean. So what do we mean by discomfort? Well, the first thing that gives us discomfort is infiltration, drafts for most of us, through the fabric of the building. Most of our buildings have very leaky fabrics. Even newly built houses to current building regulations are very leaky. Air is moving through the fabric all the time. We experience that as discomfort, and obviously also it loses a lot of heat as well. Cold surfaces, so cold window surfaces or uninsulated surfaces, mean that we get a radiant effect from the surface that makes us uncomfortable. If we've got cold surfaces, we'll tend to get cold downdrafts, and then that gives us cold feet, and again that gives us a feeling of discomfort, which we have to counteract. And finally, we generally have ventilation drafts, because most of our ventilation is provided by holes. They're often called trickle vents in new buildings, and they again will make us uncomfortable. We also often, in newer buildings, we get overheating now. So in buildings that are starting to insulate will actually tend to overheat in summer, and that makes us very uncomfortable as well. And we often got very poor indoor air quality, including in newly built buildings to building regulations. So what do? As you can see here, we up our room temperature to compensate for most of these things. So what does that mean? It means much higher bills, and not only higher bills, but higher CO2 emissions. So we're compensating for discomfort. So we say we feel comfortable, but what we're actually doing, we're compensating for discomfort. So how do we deal with that? Let's have a look. So the first thing we can get rid of is the infiltration. We can make our building airtight. We can get rid of cold surfaces by insulating well and getting rid of our thermal bridges so there are no cold spots. We can deal with downdrafts by making sure we have triple glazing so we've got no cold window surfaces facing us. And finally, if we use mechanical ventilation with heat recovery, we're preheating the incoming air so we've got no cold drafts from ventilation. That means we can reduce our room temperature and still be comfortable. So this is achieving comfort by having a well-designed building fabric. We're not needing to compensate for discomfort. In a passive house, we'll also have no overheating or very little overheating in summer because we designed for no overheating. And finally, in a passive house, we'll have excellent indoor air quality, which all leads to a greater sense of comfort. Now, just talking about the healthy indoor environment, basically our comfort and health, indoor comfort and health relies on having good air quality. Ideally we want some acoustic protection, particularly if we're in noisy areas. We don't want any mold growth. Mold is very bad for our health, so we need to avoid that. And of course we don't want overheating in summer. Now all of these things are satisfied by a passive house. We get a healthy environment that's quite quiet with stable temperatures. And what I would say to that is what's not to like about that. And actually, if you talk to people who live in passive houses, they don't usually talk about their energy bills to start with. What they talk about is comfort and the very nice air quality that they get and the lack of any mold. And just thinking about it, air quality in buildings is a complex issue because there's a whole complex of factors that influence us, from NOx and carbon monoxide emissions from maybe from gas cookers, molds, dust mites, volatile organic compounds coming off our furniture and our carpets, external particulates coming in from outside, from traffic, etc., etc., etc. And humidity, which affects us as well. So all of these things we can deal with if we've got good ventilation. And the mechanical ventilation with heat recovery filters the air, and it also ensures that we have very optimal humidity as well. So just have a look at that. This is a graph showing the sort of humidity levels that are optimal in buildings for our health. As you can see, there's a band in the middle between 40 and 60% relative humidity that is optimal. And what we find, and my own experience of building passive houses, is that they tend to sit around between 40 and 50% on average in this country. And that's the point at which we get the least problem with bacteria and viruses. A lot of people living in passive houses say they get less colds, they get less allergic problems, less respiratory problems, and so on. So that sort of comfort that you get from optimal humidity and filtered air, for many people, is the biggest feature of all. But of course, passive houses are very energy efficient, and you can see here, I won't leave you to guess which is a passive house, but the blue obviously indicates there's no heat loss. This building in the middle is actually a building retrofitted to passive house standard, the first one in the UK, but you can see that there's very little heat loss compared with the buildings surrounding it. And you get lower bills, of course, as well. Now, this is work done by the Passive House Trust last year, and what it was showing is a comparison of the regulated energy use. So that's the energy use that is calculated under the UK methodology. And it gives the average UK new build and then a typical passive house new build. And what it demonstrated was that the passive house new build overall used 55% less energy. But if you remember, we have the performance gap. So we've got the difference between theory and practice. So what does that mean in reality? Well, in reality, this is what we can expect if we include the performance gap for a UK new build, this red column, and a passive house with no performance gap will typically be about 73–75% better. So we've got a huge reduction in energy use. Plus we've got the comfort, plus we've got the health side of it. There's big advantages for us. So what do you have to do to achieve a passive house? What do you do? Well, the first thing we've got to think about is we have to start from the very beginning. So we need to be thinking about this before planning, if possible. And one of the things that's important is the orientation of the building. You need to take into account A building with predominantly north-facing windows will have significantly more energy use than a building with south-facing windows. It doesn't mean to say that we have to be south-facing all the time, but we have to take this into account and optimize it at the earliest stages. So thinking about it when we're first designing. We also need to think about the form of the building. A building that has a large surface area, a complex surface area, will have much greater heat loss than a building with simple form. This is just simple numbers. It's not a particular requirement of passive house. It's just if you've got larger surface area, you've got more heat loss. You need more insulation for the same amount of heat loss. And then we've got the obvious things. The insulation. Clearly, if we're going to be energy efficient, we need lots of insulation. This is where everybody starts. And typically in the UK, we're probably looking at about 300 millimeters of fibrous insulation. It'd be less if it's a more efficient insulation like polyurethane foam. We can build with any methodology, so we can build a cavity wall, timber frame, whatever. Passivhaus is completely neutral to that. We do need to get rid of thermal bridges, so these are the places where our insulation is compromised in some way, so it's not continuous. Maybe between a wall and the window, we need to calculate the thermal bridge there, or if something has to go through the insulation material, we have to calculate that thermal bridge. We have to be sure that there's not going to be any mold growth, and we have to know the thermal effect on the building. We need to be airtight, and airtightness is incredibly important because our airtightness even in new build in the UK is very poor. We need to take particular measures. This becomes second nature to builders once they get used to it. We used to use specialist tapes normally to ensure airtightness, but once people get used to it, it's not a difficult discipline at all. And this just gives us an idea of the kinds of level of airtightness we're talking about. So in a typical UK new build, the equivalent leakage is, well, it's the equivalent of a hole about 400 millimeters square in the fabric of the building. That allows a lot of air through. And in a passive house, the equivalent is a hole about 40 millimeters square. And if you want to put that in some sort of context, it's the difference between a hole in a wall machine and a credit card. And if you live in a leaky Victorian terrace, as I do at the moment, well, mine's somewhat improved, but if it's unimproved, you could typically be talking about this sort of leakage, a couple of hole in the wall machines. So this is what we're talking about. It makes a major difference to our comfort and to our energy efficiency. MVHR is something people worry about, mechanical ventilation, heat recovery, but these systems give us incredibly good air quality, as we've said, and they recover heat and make us more efficient. They're not something to be frightened of. There's good capability now for delivering these, so and they're a major benefit, as I say, to our health and our comfort, as well as giving us the energy efficiency we need to achieve passive house standard. And we do need triple glazed windows, mainly for comfort and to avoid mold growth. But we also need to see how we install the windows. It's very important that the detailing around windows is done carefully and is modelled. We need an accurate methodology. In this country, we build buildings not really knowing how they're going to perform. Our standard assessment procedure, SAP, which is how we, it shows us compliance with the building regulations, but it doesn't really tell us how the building is going to perform. The Passive House planning package, the methodology for Passive House, does tell us that, and tells us quite accurately. It generally predicts the performance of buildings very well, and it's a very important part of the Passive House methodology. And finally, quality assurance. If we buy products, whether we buy a car or any other product, we expect it to be quality assured. And yet if we buy a new house, it has very little quality assurance, to be honest. Building control just ensures the basics, that probably won't burn down or fall down. I'm being slightly, exaggerating slightly, but not as much as you might think. Passive House gives us a quality assurance system through certification. How much does Passive House cost? We always get asked this. Now, and then you could say how long is a piece of string? But what we can say is that if you start from the beginning, if you make sure you don't build in costs, if you add Passive House in late on in the process, so I'm just being called by somebody. Oh, okay. then it will become very expensive, and you can be up to 20 or 30% extra. But if you plan from the beginning for a passive house, then there are some irreducible costs around the extra for triple glazed windows, the extra air tightness, the MVHR system, but it's not as much as it will be if you don't plan right from the beginning of the build. Now, the Passivhaus Trust did some work last year on costs and showed that with current best practice, we could expect Passivhaus to be about 8% more than our current building standard. And these costs will fall once we roll this out more widely, so that we can expect in the future for it to be about 4%. But put this in context, that our standards are going to increase. We don't know what's happening at the moment with our Part L for this year, but we do know that the government has said in 2025 we need our buildings to be emitting 75 to 80% less CO2. So that's somewhere near Passivhaus standard. And we also have the Grand Building Mission Challenge that Theresa May announced a couple of years ago for 2030. So we know standards are going to increase. So as we go forward, what we build now, if we build to building regulations, is going to feel quite obsolete in a few years' time, and the costs are going to increase. So Passivhaus becomes nearer and nearer to mainstream. So why not build Passivhaus now? Is my question. Where has Passivhaus got to in the UK? Well, in 2009 we got our first a couple of certified projects. By 2010, we had some pioneering projects, and it was 2010 we set up the Passivhaus Trust to promote and support Passivhaus in the UK. Now we've got many examples of private houses, just a few pulled out. The slide's a couple of years old now. We've got quite a lot of social housing in the UK, quite a wide range, and there's a list here of some of the social housing projects that have been built over the last few years. We've got quite a lot of schools and offices built to Passivhaus standard. Let's say these are just examples. We've got retrofit, so some fairly large scale retrofits, as well as smaller houses retrofitted to the standard. And we've got some large scale work. So the Norwich work that I mentioned at the beginning, Goldsmith Street, 105 Passivhaus homes. Camden have built 249 homes to the standard, and they propose a lot more. And Exeter Council is now building nothing but Passivhaus on any housing provision, and this is their new leisure centre and transport interchange, which is being built to the Passivhaus standard at the moment. So Passivhaus is developing across the UK. It is still a small part of the construction industry, one has to say, but it acts as a beacon, I'd say, for the whole industry. And this was a graph from last year just showing the development of Passivhaus and from 2009 up to then 2019, which I need to update. So you're not limited building a passive house. I just wanted to show you a few examples of passive houses. This is in the Outer Hebrides. They're all award-winning projects, sort of mimicking the traditional croft appearance. This is a very simple family home. I think quite lovely in its simplicity. We've got some in Norfolk here. These are passive house, and they're traditional looking buildings, but they're actually built to passive house standards, social housing, or we can build much more modernist. You're not restricted in what you build. So don't be limited, or don't feel you'll be limited by building a passive house. So after that whistle stop tour, I just want to, in a way, talk to you about next steps for you. The first thing to ask is, a lot of people say, I'm going to build a passive house, near passive house standard, or I'm going to adopt the principles, but I'm not going all the way. So I have some questions there. The first thing is, would you leave out the passive house planning packet, accurate modelling? If you do that, you won't know how your building is going to perform, and maybe you're spending money without really knowing what you're spending it on. Would you leave out quality assurance? Now you might, if you've got a good team, you know what they're doing, and you know they can deliver, then maybe you don't need it. But if you're not sure, surely being quality assured and certifying gives you that peace of mind. I think leaving out the insulation is probably a no-brainer. You wouldn't be listening to this if you weren't thinking about going beyond building regulations, so perhaps not talk further about that. But if you're going to insulate, then you really need to deal with your thermal ridges, otherwise you're wasting a lot of that insulation by allowing heat to leak out disproportionately through your thermal ridges. Leaving out the air tightness similarly means that your insulation isn't working in an efficient way and you're not going to be comfortable. You spend all that effort and don't get the comfort. And leaving out the mechanical ventilation means that you're going to probably end up with poor indoor air quality, plus wasting energy at the same time. So what would you leave out? I put this slide up if you want more resources. So the Passivhaus Trust, there are a lot of free resources there, but I particularly wanted to point out this element, the projects database. And if you click on there, it brings you up a database of lots of projects built to the Passivhaus standard to give you inspiration. Because I think we need to feel inspired. If you're looking at Passivhaus, you think this looks really good, but actually I'm not really inspired by this. I don't know whether it'll limit what I can build. Then go and have a look and see what people have done, because it really does mean you can build what you want. So finally, your next steps if you're considering Passivhaus. I think the first thing is to say you need to learn more. Being an informed client, or obviously an informed building professional, is absolutely essential. You need to understand as much as you can, and obviously these 2 days are giving you that learning, so stick with some of the presentations. I think you'll get a lot from them. Decide whether Passivhaus is where you want to go. Is it aspirational for you? Does it make sense? Anybody who lives in a Passivhaus would tell you it's a no-brainer, but you have to decide that for yourself first of all. And then start, but start at the beginning. Start before you put pencil to paper or cursor to screen. Start before planning if you can. It will make it cheaper, much easier to do. Use people who know what they're doing, who are experienced and trained Passivhaus professionals. If you're using an architect you trust, that's fine, they haven't got experience. Ask them to also use a Passivhaus consultant working with them, and see if you can find a contractor who's experienced or is open-minded enough to learn how to do this. And commit to Passivhaus, as I've said, not somewhere near, because somewhere near will probably be not a near miss, it will be quite a long way off. And so finally, enjoy your fantastically comfortable, energy efficient, cheap to run new home. And my last point is that this is where we're going. This is the UK Committee on Climate Change, their report last year, February last year. And what they said that by 2025, all new buildings need to be built to what is effectively the Passivhaus standard. This is where the future has to go. So that's an incredibly fast rundown of Passivhaus. And so I'm available now to take questions. I'm just going to have to escape from
That's okay, Chris. I'm here, so I can ask you the questions on the attendees' behalf. Thank you very much for that. That was impeccable timing as well. It's perfect. So it's given us 10 minutes.
Yeah, well, this is all new to us, isn't it, Harvey? We've not, the first time we've done this online.
Yeah, no, that was great. So that's given us 10 minutes for questions. We've had some really interesting questions through. So I shall ask them on behalf of the attendees. Yeah, if you just want to click on stop share on your screen, Chris, that'd be great. So the first one, you mentioned the housing development in Norwich. And Christine's just asked about the MVHR. And Christine, just to let you know, we've got a session on MVHR at 2 o'clock tomorrow with Clarissa from Total Home Environment. So make sure you watch that. But Clarissa's just saying there's some cynicism amongst some people about MVHR, people not understanding how to use it, concerned about the continual kind of humming noise. Just any thoughts on that development, or just the general use of MVHR within a Passivhaus project?
Right. The noise thing first, I think you need to address. A lot of mechanical ventilation systems with heat recovery, they're used quite widely now. Widely. There's still a minority use, but they're used in quite a lot of buildings now, built to building regulations as well. The difference in Passivhaus is that the conditions for commissioning and for ultimately certifying a Passivhaus are that the MVHR should be effectively silent. So there are very strict sound criteria, and anybody designing MVHR systems to Passivhaus standard will be designing with suitable noise attenuation. So my own company, Green Building Store, we design MVHR systems and supply them. In fact, we supplied the Goldsmith Street project. we basically design so they're effectively inaudible. There are strict decibel limits, so that shouldn't be a problem. If there is a problem in a passive house with the noise and MVHR system, then we should be going back to the designers and saying what's wrong here, and trying to find out what's wrong. In other MVHR installations in non-passive houses, or possibly non-certified passive houses, it could just be that it's been badly designed, which is a very common feature of MVHR, I'm afraid, outside of passive houses.
Yeah. The next one, Chris, just because I'm going to try and get through as many as I can
in
the next 10 minutes. So Wim has asked about air quality. So depending on, does air quality depend on materials used in the build? So she's looking at volatile organic compounds, so VOCs from pipeworks, paint, cabling, etc. Is that factored into the Passive House standard?
No, it's quite interesting. Passive House standard is about the comfort and energy efficiency. So it's about the physical fabric of the building. It's completely neutral on materials, and it makes no statement on emissions from materials used either. I mean, that doesn't mean to say an awful lot of Passive House practitioners aren't interested in those things. I am, in fact, it's where I come from. It's actually my early involvement in sustainable building was around materials and wood preservatives in my case. So it is important. But the thing to bear in mind is that a passive house, even if it's built with conventional, fairly high VOC materials, will be better than a current UK building regulations house because the ventilation system is optimal. So one of the ways you deal with volatile organic compounds in a building is, and actually this is in the building regulations, is that the ventilation system needs to be able to clear VOCs to an adequate level. Now, I would always advocate that you reduce VOC emissions from materials so that you actually do that as well. And a lot of people who are involved with Passive House will also be very interested in sustainability in buildings generally, and will be looking at those aspects, maybe looking at more use of natural materials and so on. And some of the presentations we've got coming up today, you'll see, on both days, there are presentations around use of timber frame, using natural insulations, all those sort of things, all of which contribute. So yes, it's important, but no, it isn't part of the actual Passive House certification or standard.
Great, thank you, Chris. Ryan has asked about the performance gap in a passive house, and what I'm going to say, Chris, is I'm going to guide Ryan and anyone who's interested in performance gap to the talk at 1 o'clock tomorrow by Alan Budden, and he's actually doing a presentation on the performance gap and comfort benefits. So Ryan, be there at 1 o'clock tomorrow for Alan's talk. So that's your your short answer to that one.
Can I add something to it?
Yeah, of course. Yeah.
I know we're whistle stop here, but a lot of work has been done monitoring passive houses. I mean, a lot. Going back to the beginning of about 2000, I think it was a European project monitoring passive houses. And they go on demonstrating that passive houses, properly quality assured passive houses, don't have a significant performance gap. So I mean, Alan will elaborate on that, but actually, again, that experience comes up again and again and again.
Great, thanks, Chris. There's been a couple of questions actually along similar lines. So there's a question around the tapes that builders, constructors would use to ensure airtightness. Has there been any testing to sort of prove their longevity? So he's asking how long will it hold their ability to keep integrity, and therefore the quality assurance of the Passive House standard.
Yeah. Well, I'm not going to name names because that would be inappropriate for me in this role with this hat on. But some of the air tightness tapes, the one that we use, in fact, and sell. Sorry, I didn't mean. Have been tested for longevity. They do accelerated weathering tests. And one range at least has achieved 100-year accelerated weathering tests. So it's about the quality of the glues. These are not just gaffer tape or other tapes. They are specialist glues designed for the life of the building.
Great, thank you, Chris. A couple of questions I'm going to pitch to you at the same time. So David has asked, do you know what the percentage of homes built in the UK at the moment are Passive House standard compared to standard homes? And the second question is Ryan's asking, how realistic is the 2025 goal that we've set, bearing in mind we're almost in 2021 or halfway through 2020 at least?
Okay, well, very simply, that's the housing industry, and Passivhaus is okay. I don't know the number, but it's probably 0.0 something percent. It's tiny. I mean, it's still tiny. You know, we're churning out buildings that are supposed to meet the building regulations, and many of them don't even meet the building regulations. They don't even meet the fire regulations in many cases. We've heard recently of Persimmon. So you know, but yes, it's still tiny. But compared with where it was 10 years ago, when there was nothing in the UK, or sort of 10 years ago, we're moving forward. And it is informing the industry. Most of the people, a lot of the people who sit on committees advising the government will have experience of Passivhaus. It teaches you that this is the way to do it, that this works, if you like. Sorry, I lost the second half of the question there.
That's okay. I was just follow up on that from the centre's perspective. Our most well-attended events, and the events that people are most keen to visit at the centre or come online now, are our eco workshops and our Passivhaus workshops.
Yeah.
You know, so the demands there, and I think particularly in the self-build sector, people understand that the benefits of building, you know, a well-designed, energy-efficient home.
I suppose it was the 2025 target, wasn't it?
That's it. Yeah.
2025 target, yeah, it's a perfectly good comment. I've got no idea. I mean, you know, it depends what faith you have in government. The thing is that we do have legally binding targets for climate change. I'm sure that there'll be some kind of derogation of those because of the current crisis and, you know, challenges. But our challenge coming out of what we're facing now is actually to change the basis of our economy and do things right. We need to address climate change. We need to be, so in a way, it's a choice for us as a society. And I know that ultimately it's politicians that control that, but we control politicians. So I'm kind of giving you a political answer, really. I mean, yeah, it depends how you judge where they might go. In theory, it's doable. What they've done in Vancouver, interestingly, is they've set, basically said the code by 2030, their building code, everything will be effectively Passivhaus. It will have a maple leaf on it, but it will be Passivhaus. And they've set steps to that, so we can see where we're going, and that's probably a more intelligent way of doing things. I doubt very much we'll be at Passivhaus in reality by 2025, but I'm sure that the building regulations will be quite significantly tightened then. We'll just have a very big performance gap, and then addressing the performance gap will be the next steps in the next few years after that.
Brilliant. Right, and very quickly, just the last one then, Chris. That's all we've got time for. So Greg and Beth have asked the same question, actually. How much does the certification cost? Yeah.
It's not cheap, I've got to say. I mean, in terms of the build of a new build house, perhaps it's not that, but it tends to be £2,000 to £3,000 range, I think. It'll depend on the complexity of the building, but it is actually very onerous for the certifier, so they're not making a lot of money out of it. In fact, the certifiers I know, they make their money on consultancy more than certification in reality. There's a lot of work involved because there's a lot of quality assurance, a lot of detail. They don't go on site, they use photographic records, plus they're checking all the invoicing to make sure the materials you've specified are what have been used, and then they're checking the Passivhaus planning package, they rerun it completely. So there is a lot of work. So it is value, but obviously, you know, it's adding to your costs. But then, if you're building a building for £200,000-300,000 build, whatever it is, what's a couple of £1,000 to assure that you're actually quality assured?
Great. Well, Chris, thank you so much for your time, and to everyone watching, thank you very much for your time as well. That's great. We've finished exactly on time, which I'm quite surprised about.
That's
so
it,
I'm going to conclude this session and give you 15 minutes to join the next one, which is all about the key to Passivhaus, the PHPP that Chris mentioned earlier, with Jay Cottrell from Passivhaus Homes. And Chris, you'll be back at 3 o'clock for the question time session with the other panelists. The 11 o'clock session, for those of you joining that, will be hosted by my colleague Katie, and then I will be playing cameraman for our Facebook Live tour of the centre with Alan Budden at midday. So hopefully once you finish the next session at 11 on Zoom, you'll all log on to Facebook and join us for what should be quite an interesting tour of our Passivhaus exhibits and some of the displays. Chris, I think we'll be looking at the Green Building Store display as part of it. So yeah, it'd be great. That should be quite fun with Alan at midday. But I'm going to end this session now, and then we'll see you back in 15 minutes for session number 2. Thank you very much, everyone. Enjoy the rest of the workshop. Thank you.
Thank you, everyone.